Upbeat, curious music begins. Ever wonder how your phone knows exactly where you are? It's all thanks to GPS, a fantastic system that relies on a constellation of satellites orbiting our planet. But what happens when that signal gets blocked? Go into a tunnel, dive underwater, or even just walk through a dense city canyon and suddenly you're off the grid. This is a minor inconvenience for most of us, but for submarines, aircraft, and even future self-driving cars, losing navigation can be a massive problem. What if I told you there's a new technology on the horizon that could make GPS obsolete? A technology that works anywhere, anytime, without any external signals at all. Get ready to have your mind blown, because today we're diving into the incredible world of quantum navigation. So, what is this sci-fi sounding tech? At its core, quantum navigation is a super advanced form of what's called inertial navigation. Think of it like this. If you're blindfolded in a car, you can still get a rough sense of where you're going. You feel the car accelerate, you feel it turn left, you feel it brake. By adding up all those movements, you could, in theory, track your position. This is what current inertial navigation systems, or INS, do. They use devices called accelerometers and gyroscopes to measure every tiny movement and rotation. The problem is, these systems aren't perfect. Over time, tiny errors creep in and add up, causing what's known as drift. After just a few hours, a submarine using only INS could be miles off course. This is where the quantum part comes in and changes everything. Instead of using traditional sensors, quantum navigation systems use the strange and wonderful properties of atoms. Scientists have figured out how to use lasers to cool a cloud of atoms down to just a fraction of a degree above absolute zero. At these insane temperatures, the atoms behave less like tiny billiard balls and more like waves, a concept called wave-particle duality. Using a technique called atom interferometry, scientists can measure how these atom waves are affected by motion. Because the properties of these atoms are fundamental constants of the universe, they provide an incredibly stable and precise reference. Imagine an accelerometer so sensitive it can measure the tiny gravitational pull of a person walking by. That's the level of precision we're talking about. A quantum navigation system would use these ultra-precise atomic sensors to measure acceleration and rotation with mind-boggling accuracy. The drift that plagues current systems would be reduced by thousands or even millions of times. This means a vehicle could navigate for days, weeks, or even months without a single GPS signal, and still know its position with pinpoint accuracy. It's like having a perfect internal compass and map that never ever gets lost. The implications are huge. For the military, it means submarines that can stay hidden underwater for their entire mission, and aircraft that can fly through GPS-jammed territory without missing a beat. But the benefits extend far beyond defense. Imagine autonomous cargo ships crossing the ocean with unparalleled safety and efficiency, or deep-sea drones exploring the darkest corners of the ocean floor, always knowing their exact location. Even your future self-driving car could navigate through complex city tunnels and underground parking garages flawlessly. It could even be used for surveying and prospecting, detecting tiny changes in gravity to find underground resources or map unseen geological structures. Now, don't expect to see a quantum navigator in your smartphone next year. The technology is still in its early stages. These systems are currently large, complex, and incredibly expensive, mostly confined to advanced research labs. But just like the first computers filled entire rooms, scientists are working tirelessly to shrink these devices down. We're already seeing chip-scale atomic clocks, and the race is on to create compact, robust quantum sensors. The leap from the lab to the real world is a huge engineering challenge. But the potential is so revolutionary that it is a challenge the world's brightest minds are determined to solve. The era of quantum navigation is coming, promising a future where we are never truly lost again. Thanks for joining me on this journey into the future of navigation. It's a mind-bending topic, and we've only just scratched the surface. If you enjoyed this video and want to learn more about the incredible technologies shaping our world, make sure to hit that like button and subscribe to the channel. Let me know in the comments what you think the most exciting application of quantum navigation will be. Thanks for watching, and I'll see you in the next one.